Good day, everyone. In this segment, we want to look at solubility. Now, solubility is a means of comparing the extent to which different solutes can dissolve in a particular solvent at a particular temperature. Now, different solutes in a solvent to compare how they can dissolve in a particular solvent at a particular temperature that is stated. Okay, now before you can make use of solubility in practice, you must have a knowledge of the solubility curve. Yeah, we are not going to be discussing the solubility curve. Now, what the solubility curve does is to just give us an idea of how each salt can dissolve in the solvent and how each salt can be obtained at their specified temperatures. Okay, now we want to look at solubility as a definition. Solubility of a solute. So let's bring out keywords here. The keyword here I want us to look at first is solute. And the next keyword is solvent. Okay? Now, that means that for every solution, there are two key components that makes up the solution. And what are the components? We have solute plus solvent. And so if you look at the definition of solubility, it says that the solubility of a solute in a solvent at a particular temperature. Temperature is required to be specified. It's very important. Is the maximum amount of solute in moles or grams that will saturate 1 dm cube of the solvent at that temperature. It is expedient I mentioned that 1 dm cube is also the same thing, or rather equivalent to 1,000 cubic centimeter, mathematically. Okay, so that is the definition of solubility. We are going to use this concept in our calculation thereafter when other concepts are explained. So the next concept we want to look at is how do we determine solubility, determination. The first is that you prepare a saturated solution of the given solute at the specified temperature. Take note of that. Remember that you can't talk about solubility without temperature. The second is taking a known mass of the saturated solution, and what you do next is to heat, and heating it to dryness. Now, if you recall, heating to dryness is an evaporation technique. All right, heating to dryness so that the masses of the solute and the solvent, the masses of solute and solvent can be calculated. This is a standard for the determination of solubility. The first step is you prepare a saturated solution of the given solute, any solute that is given to you, at the specified temperature according to the solubility curve. Then second, you take a known mass of that saturated solution and you heat to dryness so that the masses of the solute and the solvent can be calculated. So at this point, we are going to be looking at examples of calculations in solubility. Are you ready? All right. Example 1, we want to look at calculations in solubility. Example 1. It says if 12.2 grams of lead 2 nitrate 5 were dissolved in 21 grams of distilled water at 20 degrees Celsius, calculate the solubility of the solute in moles per dm3. Okay. I am definitely going to use two methods. And the first method I'm going to use is going to be the analytical method. If we look at the question above, the first thing we need to do is to write out our parameters. We have mass of PbNO3 2, given in the question is 12.2 grams. Right? The molar mass given per mole. Now the next one given is they gave us 21 grams of distilled water which dissolved lead 2 nitrate 5. So mass of water is 21 grams. Of course, the temperature specified is 20 degrees Celsius. So we don't need that. So if we look at the analytical method, it will take the first step, step 1. Now, what is the first step? Is to find the mole of lead 2 nitrate 5. So if we take the mole of lead 2 nitrate 5, that is amount of substance. If you recall, amount of substance, which is N, will definitely give us mass of substance over molar mass of substance. So in this case, amount of substance is used as N. So we have N of PbNO3 to give us the mass of PbNO3 to the molar mass of that. And so what we do next is add our values. The mass of PbNO3 is 12.2 grams. And the molar mass is 331 grams per mole. Of course, grams and grams we cancel out. So if you use your calculator, we have 0.037 approximately moles of that. Now, what is now the analytical method? I need to explain something first then before we move ahead. If you look at the question, the 12.2 grams was dissolved in 21 grams of distilled water. Now, in chemistry, I need to mention this. 1 grams of water is equivalent to 1 cubic centimeter of water. Now, this resonates from the density of water. So therefore, 1,000 grams of water is also the same thing as 1,000 cubic grams of water. I think I mentioned this earlier in my class. Okay, so this is what we are going to use in converting the unit to dm cube. Remember that 1,000 cubic centimeter is the same thing as 1 dm cube. Now, if we go analytically, we are saying that 21 grams of water dissolves this. So therefore, we have 21 grams water dissolves 0.037 mole of NO32. So therefore, what will 1,000 grams give us? 1,000 grams will dissolve, and this is going to be this times this divided by that, over 21. Now remember that the grams and the grams will go off. So if you 0.76 moles per dm cube. So therefore, in conclusion, at 20 degrees Celsius, we are saying that 1 dm cube of water dissolves 1.76 mole of that. Now that becomes the answer. Okay, so if you have any question, of course, you can send them to my private chat. What is the second method? The second method is the formula method, which is very easy. Solubility will give us mass to molar mass times 1,000 over the given volume over volume given. Now, the volume given here can be given in terms of grams and can be given in terms of cubic centimeters. That is, this will come from your question. So if you do that math, all you are just saying is that the solubility of lead 2095 is 12.2 over 331 times 1,000 over 21. Now, if you look at all the calculations that we've been carrying out since, you discover that they will end up giving us the same answer. So whichever method you are emotionally connected with, of course, you can use. Now let's look at example 2.